What if you could hold a photograph taken moments after the Big Bang? While you can't, literally, the cosmic microwave background is the closest thing we have. This ancient echo holds the blueprints of everything around us. Prepare to have your mind expanded as we journey through this cosmic tapestry, revealing the universe's ultimate story. To understand this photograph, we have to travel back in time. For the first 380,000 years after the Big Bang, the universe was an impossibly hot, dense soup of particles and radiation. It was so dense that light couldn't travel freely. It was like a thick, glowing fog. But then, the universe expanded and cooled enough for the fog to clear. In a single, glorious moment, light was set free to travel across the cosmos for the very first time. The light from that moment is still traveling today. Over 13.8 billion years, this primordial light has stretched with the expansion of the universe, shifting from brilliant visible light into the cool, invisible microwave part of the spectrum. This is why we call it the cosmic microwave background, or CMB. It is not a place. It is a signal coming from every single direction in the sky. It is the oldest light we can, and ever will, see. It is the universe's first selfie. When astronomers first mapped the CMB, they were stunned by how incredibly uniform it was. The temperature is almost exactly the same everywhere we look. But almost is the most important word in cosmology. When we look closer, with more sensitive instruments, we find tiny minuscule variations in temperature, differences of just 1 part in 100,000. These subtle differences, these hot and cold spots, are the most important features in the entire universe. They are the seeds of all structure. The slightly cooler, denser regions had a bit more gravitational pull. Over hundreds of millions of years, these spots pulled in more and more matter, eventually collapsing to form the very first stars, galaxies, and the great cosmic web we see today. Everything you see, the planet you're on, the star it orbits, it all grew from these faint whispers in the early universe. Mapping this invisible light has been one of the greatest technological challenges in human history. In the 1990s, the COBE satellite gave us our first blurry glimpse, confirming these variations existed. In the 2000s, the WMAP satellite gave us a much sharper view, allowing us to pin down the age of the universe and its basic ingredients. But the masterpiece is the map from the Planck satellite, which gave us our most detailed picture ever, measuring those ancient temperatures with unprecedented precision. These measurements have allowed us to create what is known as the standard model of cosmology. Because of this baby picture, we know with incredible accuracy that the universe is made of about 5% normal matter, the stuff that makes you and me, 27% mysterious dark matter, and 68% even more mysterious dark energy. It's a cosmic recipe written in ancient light. But the most detailed map has also revealed the deepest puzzles. There are anomalies in the CMB that our standard model can't fully explain. A giant, cold spot that is larger and colder than it should be, and strange alignments in the patterns that hint at new physics. Are these just statistical flukes, or are they cracks in our understanding of the universe? Scientists are now searching the CMB for the echoes of an even earlier moment, the search for primordial gravitational waves. These would be ripples in space-time itself, generated in the very first fraction of a second after the Big Bang during a period of rapid inflation. Finding them would be like hearing the sound of the starting gun for the universe. It's the next great frontier in decoding this ancient message. The CMB doesn't just tell us where we came from, it contains clues about where we are going. By precisely measuring the universe's ingredients and its expansion rate, we can predict its ultimate fate. Will it expand forever until it's a cold, dark, and empty void? Will dark energy tear the very fabric of space-time apart in a big rip? The answers are encoded in those ancient temperature fluctuations. In the end, studying the cosmic microwave background is a deeply human endeavor. It connects us to the very beginning of everything. The carbon in your body, the iron in your blood, the elements that make you you, were forged in stars that only exist because of those tiny seeds planted 13.8 billion years ago. The CMB reveals our profound connection to the cosmos and our place within its grand, unfolding story. We are, in the most literal sense, the children of those cosmic whispers. Thank you for watching.